In this unit, which is the second lesson under topic 1, stoichiometry, we'll be looking at the SI base units. So meaning that anything that you're going to measure, which is a physical quantity. So a physical quantity is any measurable quantity. Okay, so any physical quantity here which is measurable, we need to give it a unit for us to specify. There are so many physical quantities, but the ones which are basic, anything that you can think of, you can touch, you can see, is classified under these physical quantities. So the first one is mass. So the physical quantity, if you're measuring something in mass, the name of the unit is a kilogram, the abbreviation is kg. If the physical quantity is length, like distance, we talk about maybe in miles and all that, the basic thing of it is meters. So a meter is the measure of length. That's in the basic sense, like the smallest part you can think of for a length is a meter, which is small letter m. Then when it comes to temperature, the name of the unit which measures temperature, the basic unit of temperature is Kelvin, which is K, and for amount of substance, which is mole, amount of substance contained in a material, we call it a mole, and the SI unit, the abbreviation for it is MOL in small letters. And time, okay, is a physical quantity because we can measure time. That's why it's a physical quantity. So the base unit is second, and the symbol is small letter s. Electric current, an ampere, which is capital A. And then luminous intensity is the Candela, which is CD. So it is important for you to know these base units. Okay, know these base units and get to know their abbreviations as well. Let's move on to the next section. So apart from the base units, there are also what we call the non-SI physical quantities in common use. Now remember that these ones, okay, these ones are also physical quantities, but they are not base units. We can measure them. So normally we say these are derivatives. We say they are derivatives, meaning that they are derived, they come from the basic units which we have talked about. So we have got volume. So the base unit, the physical quantity volume symbol is capital V, and the unit we normally use is a liter, which is capital L, and the conversion is 1 liter is equals to 10 to the power negative 3 cubic meters, meaning that 1 liter is equal to 0.001 meters cubed. So meaning that 1 liter we have to cube. So whenever you see 0.001, it's basically 10 to the power negative 3, because we're moving this point from the negative like that, and we'll move it 3 times. So it will carry that negative, as we already know from high school. Then length for microscopic systems, length we use what we call an angstrom. Like for example, if you want to measure the diameter of an atom, which is very tiny, you cannot use meters because a meter is a very big unit. So we use what we call an angstrom. And an angstrom, it's a symbol which is like this. Okay, for very small quantities, with like a 0 there on top. So an angstrom is equal to 1 angstrom is equal to 10 to the power negative 10 meters. So meaning that 10 to the power negative 10 meters make 1 angstrom, which is very, very tiny. Then we also have got pressure, which is pressure capital P, and pressure is measured in atmosphere, okay, which is called an ATM. So when you see ATM, we mean pressure in atmosphere, and 1 ATM is equals to 101,325, which is 101,325 pascals. So the PA there, it means pascals. Later on, we'll understand how this unit comes about. And also pressure is also discussed in bars, which is this bar is equals to 1 bar is equals to 100,000 pascals. It's also measured in torr, which is 1 torr. You can even see they have symbol abbreviation, so you have to know this if you want to excel fast in chemistry. So 1 torr is equal to 133.24 pascals, and these are millimeters of mercury. All these are units of pressure. So 1 millimeter of mercury is equal to 133.25 pascals. So you just have to kind of memorize these things, I would say, so that whenever you are calculating, you should easily remember, and make sure that these things are on your fingertip. Then when it comes to energy, which is E, we use electron volt. We'll see this a lot in electrochemistry. So EV is equals to 1 electrovolt is equals to 1.601 times 10 to the power negative 19 joules. That is what it means to have 1 electron volt. So then again, we have got temperature, which is called degree centigrade. Most of you are used to degree Celsius, and 1 degree Celsius is T minus 273.15 Kelvin. This is a unit of measurement. Okay, so this is a conversion from a degree Celsius to Kelvin. So sometimes the way we say this is also written as, you can also write this as temperature, which is, we're going to give it, if you want to find temperature in Kelvin, it's going to be equal to 273.15 Kelvin plus what we call the degree Celsius, whatever you find on the degree Celsius. This is the common used unit as we go forward. Then the other thing we need to know is concentration. So concentration is molarity. We see and that molarity capital M is mole per liter. So these are also the commonly used SI units, which we have to also know. Then also there are also what we call scientific or exponential notation in a way of expressing numbers that are too large or too small. You find that when you're calculating, there are numbers which will become very big, such that writing them will be tedious. Consider a situation where you're writing a number, let's say you have found 123,092,486,579 grams. So this is one number which is about close to 123 billion. So when you're calculating, you can't always be writing this number, it's too big. So what you need to do is you have to write this number in what we call scientific or exponential notation to make it shorter. Okay, even if sometimes the number can become too small, maybe you're writing 0.00130450. So these numbers are very, very small, such that you can't always be writing this, you'll be wasting time and space, so you have to put them in scientific notation. So now, how do we put a scientific notation? So there are two things we are going to learn. The first one is, let's learn the normal way. For example, a decimal notation. If you are going to have 2, in a scientific notation is 2 times 10 to the power 0. Simply because 10 to the power 0 is basically 1, and 2 times 1, 2 times 1 is basically 2 there. Then 300, you can write this as basically, you see this, so meaning that we have moved the point here 1, we have moved the point, how many times? 1 and 2. So that's why we put 10 to the power 2. And this number, you move this point 1, you move 1, you move it 1, 2, 3. So it become, the decimal point has moved between 3 and 4 there. So it is now going to become 4.3. 2176 times 10 to the power 3. Then later on, you are going to learn significant figures where you are going to be reducing this number to a certain number of significant figures. Then, for example, this is negative 5300, so you can write this as, there's a point there at the end of the 0, then you're moving it 4 times, and then it will be between 5 and negative there 5.3. So that's why here you're finding that it's becoming negative 5.3 times 10 to the power 4. As you can see also, this number is big, so all these numbers, look at them closely, they have all been taken to scientific notation. And check out, this one specifically, there is a 0.2, meaning that we're taking this point, moving it coming from the left going to the right. That's why here we're putting -1. And then this one, it's going to be like that. And then if you're moving a point going to the right, it will carry the power there, a negative. But you know, sometimes, again, because we've got this situation, sometimes it becomes tedious. So what we use are what we call a prefix. So a prefix is something that comes before the actual unit, the actual measurement. Pre means before the actual measurement. Let's say, for example, I have 1000, right? The other way I can write 1000 is 10 to the power 3. Now, this 10 to the power 3, there's a prefix for it, it's called a kilo. Now, consider that these were grams, right? And then I write 10 to the power 3, meaning that I'll have 10 to the power 3 grams. So if I change at 10 to the power 3, what is it? 10 to the power 3 is a kilo, so which is the symbol is K. I'll just put kg, meaning that this is 1 kilogram. Where there's a kilo, I can substitute with 10 to the power 3. Okay, let's look for another one. Let's say, for example, I have got, let's say, 2.23, let's say 223,000. So the way I can write, let's put this as moles. If this is the number of moles, forget the point there. So meaning that this guy here is going to become 23, and this 10, these zeros here they symbolize. We can write this as times 10 to the power 3 moles, but 10 to the power 3 is a kilo. So 10 to the power 3, now we're going to write it as 23 kilomoles, meaning that it's a prefix, meaning that it comes before the actual unit. So these are the prefixes that we'll be using as we go in our measurements. We have got the deci, we have got the cent, the milli, micro, nano, and pico. Then we've got the mega, giga as we go forward. So make sure that you know even their factors, these ones, which are here. So we'll be using them so handy as we go forward. I hope that's clear. So, for example, these are some of the examples which we have been putting. So, for example, this one, mass is equal to 5.01 milligrams. So, where there's a milli there, an m, that's what this number represents. That's why there is a substitution of the 10 to the power -3. So, you shouldn't be surprised when numbers are changed like that. So, like for example, 1.00 decimeter cubed, well, a deci is basically a 0.1. So meaning that where there is if it's decimeter cubed, meaning that the whole deci and the meter were cubed. So meaning that we have a deci is a 0.1, then it will come a meter, and then we're going to cube them. That's what this means. Okay, this also it comes in the same line with volume. A centimeter, a centi is a 0. If you check a centi here, it's a 0.01 in terms of meters. Okay, so this 1 centimeter is equals to 0.01 meters. So meaning that where there is a centimeter, we're just gonna cube it for it to become cubed, and that's how we evaluate. So if you check closely here, this is what all it means. Let's look at the last part of it. If you check nicely here, we have got 1 milliliter. So another way of writing 1 milliliter is 1.00 times 10 to the power. Why? Because a milli, right? A milli here means 10. It stands for, it's a prefix, it's a 10 to the power -3. So that's why where there's a milli, we have put with the number it represents, which is a prefix, and then we've got that. I hope this makes some sense. So here are some of the solved problems. You can take a look at them, try to solve them and practice them, and then these are the answers. So you can try to pause the video at the point of solving. you solve, and then you check out the answers. All right, that's all for this second session. It was lengthy, but the next one will be shorter. I hope you have enjoyed and you have understood what we have been learning.